All right, Chapter 3, Section 3.1, Pairs of Lines and Angles. First thing we're going to talk about are parallel lines, skew lines, and parallel planes. Two lines that do not intersect and are either parallel or skew lines. Two lines are parallel when they do not intersect and are coplanar. Remember, coplanar means they lie on the same plane. Two lines are skew lines when they do not intersect and are not coplanar. Also, two planes that do not intersect are called parallel planes. So let's look at this. On this example here, I have a picture for you. All right. You know that lines, M and N, remember, if I don't have points, I can use the lowercase letters, are parallel lines. Okay, so we would write this as M is parallel to N. So we have two lines that go the same. That means parallel to. All right, so this two straight lines means parallel to. Also recall that parallel lines use small directed arrows to show that lines are parallel. All right, so if we look here, there are our two little arrows, small directed arrows to show that those two lines, so M is parallel to N. All right, so by definition, two lines are skew lines when they do not intersect and are not coplanar. So if we look at this one right here, K does intersect N. So we know that they can't be skew, but it does not intersect M, and they are not on the same plane. All right, so they're not on the same plane. So we can state then that lines M and K are skew lines. And as they're telling us here, we can have parallel lines. We can also have parallel planes that do not intersect. So we can say that planes, now remember, planes are used sometimes named with a capital letter. It's usually in the corner, all right? And it's not by a point. So we can say that planes, TNU, are parallel planes. Again, we could say, if we wanted to use our nomenclature there, we could say that T is parallel to U. Okay? All right, example 1. Think of each segment in the figure as part of a line. Which lines or planes appear to fit the description? So lines parallel to GH and containing point F. So they're parallel to GH and contain point F. Remember, they have to be on the same plane. So we would say those two are on the same plane, and they're like railroad tracks. Parallel lines, think of them as railroad tracks. So we could say then that it's EF. And remember, we're talking about lines, so we better have a line symbol over it. Let's see, lines or line skew to GH containing point F. So remember, on that one there, here's GH. Again, it can't be on the same plane, so we know it can't be this one here that contains point F. But we know that if we're going this way here, BF is not on the same plane. All right, so everybody see that one? So we would again say point line BF, and then lines perpendicular to GH and containing point F. So remember, if they are perpendicular, that means that they're going to meet at right angles. And this one they're not telling you, but if it's a box, you're going to assume that it does go at 90-degree angles. So we know we have GH here. Here. I've been doing so well using my pointer here. So here's GH again. That contains point F. That would be this one right here. And again, it doesn't look perpendicular, but since you assume it's a box, we know that they do meet at right angles. So we would say on that one there, we would say line FG, and again, put the line symbol over above, and then D, planes parallel to plane GHD. GHD is this plane right here. Oops, I did it again. GHD is this one here. Remember, we can name a plane by 3 lines that are not collinear on the same line. So we can name 3 planes. We can name a plane by 3 points that are non-collinear. So on this one here, which is one that is parallel to it. All right, again, think of the boxes being parallel planes there. So we can take this one here and we can name it by any of the planes. The 3 points. So I named it plane. And I used ABF. Remember, you could have used any 3 of those ones there. All right, here's another postulate. So if there is a line and a point not on the line, then there is exactly one line through the point parallel to the given line. So what it's saying, there is exactly one point P, and again, we can only draw one line that is parallel to it. Again, if I even just did a little one like this, it is not parallel, all right? There's only one, always, okay? So that's that postulate, and then there's the perpendicular postulate. The perpendicular postulate states if there is a line and a point not on the line, then there is exactly one line through the point perpendicular to the given line. So there's only one line, just kind of like I was just telling you earlier with the parallel, there's only one that's perpendicular. And again, it might be, this one's 90 degrees, it might be 89 degrees, right? But we know it's still not perpendicular, only one, all right? So example 2 here then states that the given line markings just show how the roads in a town are related to one another. So name a pair of parallel lines. So if we look at parallel lines, remember parallel lines have arrows. So if we look here, we have an arrow here and an arrow here. All right. Those are, and we're not talking about the ones on the end. Those are stating that they're lines and they're continuing forever. This one right here, remember, if we talk about it, it's a ray, all right? But again, they said that we have to assume that it's going in both directions. So our line would be GK remember, I could call it GM if I wanted to, is parallel to line HL. And then said name a pair of perpendicular lines. This one was hard to, I tried not to get that little circle there, but again, they are showing you the little square there, which shows perpendicular. So again, we're going to look at this line here, and we have to go with the one that is on the box, at least for right now. We'll talk about it later. But right now, we have to just take that one there. So when we look at it, that will tell us we have line GK. And remember, the perpendicular symbol looks like a upside down T. And we would say that is JL. Okay, now it's asking if we think that GN, so this one here, is perpendicular to JL. All right. Now, you know, it doesn't look like it, but we can't just say just because it looks like it, you have to use the theorem. And we just talked about it on the perpendicular postulate. So we would say no. The perpendicular postulate states there is exactly one line through points G that is perpendicular to line JL. And we just said it was GK. All right. So again, we use the postulate to disprove something. All right. So now we're going to look at a transversal. And a transversal is a line that intersects two or more coplanar lines at different points. All right. So on this one here, what we're looking at is here's our transversal. A lot of times I'll name it by T, but again, by definition, it has to intersect two or more coplanar lines. So those lines are coplanar. We could even have those two and another one down there that says at least two or more. So we could even have 6 of them if we wanted to. But again, we're going to look at the angles that are formed by a transversal. And I'm going to show you kind of what we should see here, and it should help. So two angles are corresponding angles when they have corresponding positions. For example, angle 2 and angle 6 are above the lines and to the right of the transversal T. So what they're saying here is I have one right here that corresponds to the same one there. So notice they're both on the top of the line and that they are on the right side of the transversal. So they're on the top of the line and they're on the right side of the transversal. An easy way to remember these, ladies and gentlemen, is I'm going to show you 3 different ways that you can see them. All right. And the first one I'm going to show you is F angles. So corresponding angles are F angles. And what I mean by that is if I draw the capital letter F Okay, I just drew the capital letter F, and notice that it still says what they said. It's on the top and the top of the F. All right. Again, if I went the other way, if I went this way, because again, I can be dyslexic, I can have a backwards F. I would have the same thing. I could have one here and one here, and those would also be corresponding angles. All right. So corresponding angles are F angles. Alternate interior angles. Two angles are alternate interior angles when they lie between two lines. So they're on the interior. So if we look here, this would be the interior of the two lines. And then this here and here, those would be exterior, or the outside of those two lines. All right, so we're talking about alternate interior angles. And again, let's see, I'm going to show you a pattern. So alternate interior are Z angles. All right, so again, look at what I'm kind of saying here. I can draw a Z there. And if we look, they're alternate. And again, they're even on the inside of the Z. All right. We could say even the same thing for alternate exterior angles. So again, if I do this, again, because I just said we can be dyslexic, we can see letters backwards. And again, if you look at it here, you have one here and you have one here. Again, on the opposite sides of the transversal, and they are outside of the two lines. So they're on the exterior. That's why we call them alternate exterior angles. And then the last ones are two angles are consecutive interior angles when they lie between the two lines. So they're on the interior of the two lines and on the same side of the transversal. So here, why don't you tell me what kind of pattern we have here? All right. To look at that, all right, we show a C pattern. So let's see, consecutive interior angles are, if you think about it, it's kind of a block C, or C angles. Okay, all right, so I kept those big for you so we could see them, and now we're going to talk about what we can identify. So we're going to identify the pairs. This is our last problem. So corresponding, remember, I just told you we can make an F angle. So if I can make an F angle here, what color did I use? I'll use the same color. So I used this red here. I can make an F angle. So there's my F angle. And then look at the ones that are corresponding. Again, the tops of the F's or the bottom of the F's. So here's the top of the F. All right. So we can say angle 1 and angle 7. All right. If we look at the bottom of the F on that one, we can say angle 8 and angle 6. All right, now I'll erase that one because we still have the other ones. So if we go this way, again, notice that they're not going to be perfect letters right now. We're going to talk more about what happens when the lines are parallel. All right, but again, same thing here. I have the 2 on the top, so I can say angle 2 and angle 4. And I can say angle 3 and angle 5. Again, those follow an F pattern. Okay, how about alternate interior? So if we look at it, I'm just going to go ahead. Here's the interior of the 2 lines. All right, and I used the Z pattern. So I'm going to say the interior here. So let's see. If I look at it here, again, the transversal is the one that is in between them. So it didn't put a T there, but you should know that's the transversal because it's the one that cuts 2 lines. And again, there's my Z pattern. And it's since we're talking about the interior, all right, those are on alternate sides. So angle 3 and angle 7. And if we wanted to go with the other way, so if I go the other way, it would be 8 and 4. All right, so while I have that one already up, what would be the exterior angles for that one? Alternate exterior. So there's my Z, an alternate on the outside of the 2. So we would say angle 1 and angle 5. And let me erase that one and go back to the other one. So if I make this Z here, and the ones that are on the outside, on the opposite sides of the transversal, it would tell me angle 2 and angle 6. And finally, the consecutive interior angles. So that again on the interior, and they make a C. So if we look at it here, there's one of my C's. So it would tell me angle 3 and angle 4. And if we erase that and go with the other one, we would say angle 8 and angle 7. That's it, people. Pretty straightforward. We'll learn more about these as we go through the chapter.